Hello everyone, myself Sravanthi, working as Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is conversions of finite automata to regular expressions. In the last class, we have discussed what is a regular expression, what are the laws and algebraic laws and identity rules we have seen. So the next is conversions of finite automata to regular expression. There are two popular methods are there for converting a DFA into its regular expression. So to convert a given finite automata to regular expression, there are two methods are there. The first one is state elimination method and the second one is Arden's method. There is a Arden's theorem. From that Arden's theorem, we are going to take the formula and we are going to apply over here. So these are the two methods that are used for converting a DFA to its regular expression. Let's move to the first one, state elimination method. So what are the steps that are required to convert a given finite automata to a regular expression? The steps for state elimination method are: the step 1, the initial state of the DFA must not have any incoming edge. So if I, in our DFA diagram, for example, this is my DFA diagram Q0 A, and suppose here I have B. The initial state of DFA must not have any incoming edge. So if I find any incoming edge for the initial state, then I need to create a new state. Then create a new initial state having no incoming edge. Having no incoming edge is nothing but we are going to create it with epsilon most. So what it will be means, here Qi, I am taking some Qi is a new state. From Qi to Q1 epsilon, Q0 and B, Q1 A. So if I find for the initial state, if I find any incoming edge for the initial state, then create a new state with no incoming edge. With no incoming edge. No incoming edge is nothing but keep it as epsilon. Epsilon is nothing but 0 moves. Epsilon transitions, null moves. Okay. See here in Q0, I am having B as a incoming edge. B as a incoming edge, Q0 on B, it is coming to the Q0. So as it is my starting state, so I'm going to create a new state, that is Qi, and that will be our starting state. So initially it is Q0 is my starting state. Now Qi is our starting state with epsilon moves. Epsilon moves is nothing but 0 moves. Now check it. The initial state is Qi. Any incoming edges are there? No incoming edge. So the first step is satisfied. Then next, there must exist only one final state in DFA. So here in our diagram, so we should not have any multiple final states. If we find multiple final states, then we need to create only one final state. For example, see Q1, Q2, Q2 is my final state and Q3 is my final state. Q1, Q2, Q3. These two are the final states. So what I need to do, multiple final states are not there. So we are going to create one new state Q1, Q2 and Q3 and one final state, that is QF. So these will be our final state and these two are plotted here. Okay. So this is nothing but the final state. So only one final state should be there. The final state of DFA must not have any outgoing edge. Nothing but from final state, there should not be any outgoing edge. For example, see here, from Q1 to Q0, some outgoing is B. B is the input symbol. From Q1, I am moving to Q0. So if I find this type of diagram, we need to create one more state as final state and that will be our final state. So by epsilon moves. Epsilon moves. See, the final state of DFA must not have any outgoing edge. If there exists, then create a new final state and having no outgoing edge. There should not be any outgoing edge. Eliminate all intermediate states one by one. Eliminate all intermediate states one by one. So what are the steps required to find out the regular expression using a state elimination method? The first step is it should not have any incoming edge for the initial state. If we find any new incoming edge for the initial state, create one new state and make it as the start state. The next one is there should not be multiple final state. If we find multiple final state, create one state and make that state as a final state. And the third point is the final edge should not have any outgoing edge. If we find any outgoing edges, create one state. That state is our final state and make no epsilon moves. Nothing but make incoming 0, outgoing edges. Next, eliminate all the states. Eliminate all the intermediate states and keep a initial state and final states only. So that shows us the regular expression. So the first example is Q1. So this is our diagram. This is the some DFA diagram. So from this diagram, we are going to construct the state regular expression for this finite automata. For this finite automata, we are going to construct the regular expression. So let us go for the first step. So what is the first step we are having? It should not have any incoming edge. The first step we are having is no incoming edge. No incoming edge for starting state, start state. And the second point is no multiple final states. The third state is no outgoing for final state. And fourth point is remove intermediate nodes. So let us start. See here, the Q1 is our start state. Check any incoming edge. Yes, C is the incoming edge. It is coming. So create one new state. So that will be our starting state Qi. And next, it is having no incoming edge. So that is nothing but epsilon moves. Next Q1 C, that is there. Next A Q2 B D. So the first step satisfied. It is now check it. The initial state is Qi. There is no incoming edge. That is satisfied. The next step. So check any multiple final states are there. No, only one final state is there. That is Q2 is our final state. The third point. So check any outgoing edge from the final state. Yes, from Q2 to Q1 there is outgoing edge. That is B. Q2 on B, it is moving to Q1. So create one new state and make that new state as a final state. So Qi epsilon Q1 A B Q2 on D. So this is not our final state. We are going to create one new state. That new state is our final state QF. Take any name. I am taking it as F. So check now whether it is satisfying. See from QF the new state, any outgoing edges from QF, there is no outgoing edge. So it's satisfied. So the first condition is initial state satisfied, no multiple final states satisfied. The third one is final state, no outgoing edge from final state, that also satisfied. So the next one is we are going to remove the intermediate nodes. After removing the intermediate nodes, so only we should have the start state and the final state should be there. That shows us the regular expression. So the next, we are going to remove the intermediate nodes. So first Qi. See here. So before this, so if I am having a self loop, some self loop Q1 to QB A, and if I am having a self loop, what we are going to write? Self loop is nothing but I am going to repeat that any number of times. Nothing but star, clean closure. I can write it as C star A. Right? If I have Q1, Q2 on A and on B. If I have this one, so how I can write either A, A, B, nothing but either A or B. So I can read it as Q1, Q2 as A plus B, A or B, I can read. Same way here, I am going to remove this one, C. So what I am going to have here, first let me write here Q1 A, Q2 B, D, epsilon QF. See here, Q1 is having a self loop. Self loop is nothing but it's a multiple times I can repeat that one. So nothing but I can write it as closure. C star A. Q2. So the next I can do is, next I am going to eliminate is, see here C star A and I have B. C star A. So what I can write it here as Qi, Q1 C star A, Q2, D, epsilon, QF. So these A. So how I can write? So from Q1 to Q2, C star A, B, C star A. Yes. So how I can write this one as self loop, B, C star A. Why I am writing here? So from Q1 to Q2, there is C star A, and come to Q2. Again from Q2, I can move to the Q1 with the help of B. Again to reach Q2, again I have C star A. Again to move from. So this is nothing but it is repeating and it is in opposite directions, opposite operations. So I can write it as Q2, D is there, B, C star A is there. So let me write here QI. So epsilon moves, these are epsilon moves, Q1, C star A, Q2, epsilon, QF. This is our final state. So here I have D and B star C. D and B star C. So I can write it as D plus B C star A. D B C star A whole star. As it is in a loop, so I am writing it as whole. So now I can eliminate this one. Then how can I write? QI, QF. So what I am going to have? C star A into D plus B C star A. D B star C star A. So this is our expression. So how we got this? So first here what I am going to do? C star A. So as it is in a self loop, we are going to write it as a closure. C closure A. Then next I am having C closure A, again B. From here Q1 to Q2 to move from Q1 to Q2 again to Q2, C star A, B, C star A it comes. So that I am writing it as a self loop because here I have B is there. So B, C star A. So D and B pointing to the same Q2. Either I can take D or B, C star A. So it is in a self loop. So we are going to take it as a closure. See here from Q1 to Q2 there is C star A, D, B, C star A. So that we are going to write it as this one. The regular expression is C star A, D plus B, C star A whole star. So this is the regular expression using state elimination method. So we are going to eliminate one state. So then we are going to get, this is the regular expression we are going to get. So the next state elimination method. Example for state elimination method. Here we are going to have the 3 states. Check whether the same steps are going to be checked. The first step is check whether any incoming edge for starting state. Here Q1 is our start state. Check any incoming edge. There is no incoming edge. Check any multiple final states. Only one final state, that is Q3. Next, check any outgoing edge from Q3. Any outgoing edge? There is no outgoing edge. Only incoming edges are there. So all the conditions are satisfied. Then we are going to start eliminating the steps. So Q1. Let me draw this diagram in different way. A, Q2. Next Q2 to A, Q3. Q3 is our final state and it is having A, Q1 to Q2 and Q2 to A. So Q1 to Q3 it is B. Q1 to Q3 it is B. So now what I am going to do is, so we need to eliminate the intermediate states. Eliminate the intermediate states. So the next one what we are going to have, Q1 as I can eliminate Q2. Yes, I can eliminate Q2 and I am going to have it is as AA and from directly I have B. Yes, or else let me write that one. AA and again I have B and A. See here, I eliminated Q2 states. If I eliminate Q2 state, AA. So from Q1 to Q3 there is B. And from Q3 there is a self loop A. So this is it. The next step is AAB. So how I can write it as, it is having, so Q1 to Q2 I have A and from B is also there. Nothing but I can write A plus B. Either I can read A or I can read B. Because from same state, same start state, I'm going to the final state either with AA or B, anything. So how I can write Q1, Q3, final state, B plus AA, B plus AA, and this is A. So now next I am going to remove this whole star also. So Q1, B plus AA, Q3, A star, right? So this is our regular expression. Only two states are there, that is start state and final state. So what will be our regular expression is, the regular expression for this grammar, for this finite automata is B plus AA, A star, B plus AA, A star. This is of state elimination method. Thank you.